Hi everyone, let's discuss how to find the area of a quadrilateral. So let's take a quadrilateral. This is a quadrilateral with the vertices A, B, C and D. Now we don't know how to find the area of the quadrilateral. Now what we can do is, we can split this quadrilateral into two different shapes whose area we know how to calculate. And what we can do here is we can take the diagonal, say AC, and now the two shapes that emerge out are two triangles. And we know very well how to find the area of a triangle. This is one triangle and this is another triangle. And the area of a triangle we know is, for a triangle with height h and base b, the area would be half into height into base. So what we can do is, we can find the area of both the triangles and then we'll add it up and say that that is the area of a quadrilateral. So let's see about this triangle. First we need height. So we need a perpendicular from the vertex B. And let's take the diagonal AC as base. Then the perpendicular drop from B would be here. And this is the height. And this would be the base. Let's call it H1. Similarly, the perpendicular from D on the base AC would be this. This is the height of the pink triangle. So this is, let's say, H2. Then the area of the yellow triangle is half into H1, which is the height, into base AC, because this is the base. And similarly, the area of the pink triangle would be half into H2, which is this height, into the base, which is AC. So the area of quadrilateral would be the summation of these two areas. So we have the area of this triangle as half H1 AC and the area of this triangle as half H2 AC. So the area of quadrilateral is equal to half H1 into AC plus half H2 into AC. Now we can take half into AC common to give us half into H1 plus H2 into AC. And this becomes a very clean formula for us to see. But now, a question you might ask is, okay, we took this diagonal as the base. But what if in this quadrilateral, we took this diagonal as the base? So let's look at that. We again have our same quadrilateral here. And let's take BD as the diagonal now. So BD is our diagonal. And these are the two respective triangles we get. So if we have to consider BD as the base, then one triangle is this and the other triangle is this. And let's take the perpendicular drop or the height of this triangle. Let's call this H3. And similarly, the perpendicular drop or the height of the pink triangle would be H4. And so the area of the pink triangle would be half into H4, but this time the base is BD. And the yellow triangle, the area would be half into H3 into the base BD. And so the area of quadrilateral is also equal to the summation of these two areas. But the area of quadrilateral remains constant. So that is equal to this only. So we have this also equals half into H3 plus H4 into BD, which is the summation of these two areas. So to curb out the confusion here, which area does it equal to and which formula we should write, let's try to form a generic formula of this, which we can say is the area of quadrilateral. So let's take both of them here, and we have both these areas being equal to each other. But one thing you have to note here H1, H2 and H3, H4, they have a similarity. Why? Because both of them are just sum of perpendiculars on diagonal from remaining vertices. So in the first quadrilateral, we take AC as a diagonal. So our summation is of perpendicular from the other vertices to this diagonal. Again, in the second quadrilateral, we took the diagonal as BD. So the summation is of perpendicular drop from the remaining vertices. So this makes the formula very generic now, because now we can write the area of quadrilateral simply as half into H1 plus H2 into D, where H1 plus H2 is nothing but the sum of perpendiculars on diagonal from remaining vertices, and the diagonal in question is D. So if we had taken D as AC, then H1 plus H2 would be this H1 plus H2. Had we taken D as BD, which is this diagonal, then this h1 plus h2 would be the perpendicular drop from the remaining vertices, so it would have been h3 plus h4. And so this is our general formula for the area of quadrilateral, where this is a diagonal. Now another question you might ask is, why did we take so much hassle? Because in this triangle, if you zoom it up, it's pretty clear that if we had this in an isolated environment, we would not have taken the perpendicular like this. We would have simply dropped the perpendicular from D like this, right? Then why did we take it here? And that is simply because we can take BD as common out in the formula, and we have a much more generic formula that we can use. But in different situations, our objective, you should remember, is simply to calculate the area of both the triangles. And in whichever way it is easier for us, we'll do it. So in another situation, we might just take this perpendicular and try to find the area of this triangle. And let's see an example how. Because now, let's try to find the area of a parallelogram by the same method. So we have a parallelogram like this, and the vertices are A, B, C, and D. And again, we can take a diagonal here, say AD. And now, in our earlier method, we are dropping perpendiculars from the remaining vertices onto the diagonal. So we have this perpendicular here and this perpendicular here. But really, for a parallelogram, we have to exploit the properties of parallelogram. So instead of taking the perpendicular drops of the remaining vertices on the diagonal as the heights, ultimately our objective is to find the area of triangle, right? So a much easier way of that is if we take the perpendicular drops like this, because this is h, and because this is a parallelogram, this is also h. So now we can write the area of each triangle as half into h into CD. This is the height, this is the base, plus for this triangle, half into h into AB. And now for a parallelogram, AB, the opposite sides, AB and CD, they are going to be equal. So here we can replace AB as CD. So we have half into h into CD plus half into h into CD. And they are the same thing. So this becomes h into CD. And that is simply what an area of parallelogram is, where h is the height of the parallelogram and CD is the base of the parallelogram. There are different methods to calculate the area of quadrilateral and parallelogram. The underlying objective remains same, and that is we are breaking the quadrilateral into two triangles and we are adding the area of each of the triangle. So that's about it. Thank you.